Forest carbon sequestration. A forest absorbs and stores carbon dioxide from the atmosphere. The rate at which carbon is sequestered in the forest is described by the function St equal 1000 e to the power of 0.05 times t, kilograms per year, where t is measured in years. Find the rate of change of carbon sequestration at t equal 5 years. Explain the significance of this rate in the context of combating climate change and promoting sustainability. First, find the derivative of the function Ct equals 1000 e to the power of 0.05 times t with respect to t, and then evaluate it at t equal 5. So to find the derivative, we will apply the chain rule. Equals 1000 times 0.05 e to the power of, we write the same, so 0.05 times t equals to 1000 times 0.05 is 50 e to the power of 0.05, and then t we will replace it with 5 because it's in 5 years. Put this all in the calculator and the answer would be 64.2 kilograms per year. So at t equal 5 years, the rate of change of carbon sequestration is approximate to 64.2 kilograms per year. So now let's explain the significance of this rate and the concepts of combating climate change and promoting sustainability. So firstly, we will talk about climate change mitigation. The positive rate of change in carbon sequestration is 64.2 kilograms per year, indicate that the forest is actively absorbing and storing carbon dioxide from the atmosphere. This is significant for combating climate change because carbon dioxide is a major greenhouse gas responsible for global warming. By sequestering carbon, the forest helps reduce the concentration of CO2 in the atmosphere. Mitigation, the greenhouse effect and its associated impacts. Secondly, carbon offset. The rate of carbon sequestration contributes to the concept of carbon offsetting. Organizations and individuals can invest in activities like reforestation and afforestation projects to offset their own carbon emissions. The rate at which carbon is sequestered in this case is 64.2 kilograms per year, represents a measurable and valuable contribution to carbon offset initiatives. Thirdly, sustainable forest management. Sustainable forest management practices that promote the health and growth of forests and essential for long-term carbon sequestration. The positive rate of change in sequestration emphasizes the impact of protecting and conserving forests as virtual carbon sinks, supporting biodiversity and enhancing ecosystem services. Fourthly, ecosystem health. Carbon sequestration is not only important for climate change mitigation, but also for maintaining the overall health and resilience of ecosystem. The forest's ability to store carbon reflects its capacity to sustain biodiversity, improve air and water quality, and provide habitat for wildlife. In summary, the rate of change of carbon sequestration at t equals 5 years signifies the forest's role as a carbon sink, actively removing CO2 from the atmosphere. This rate is highly relevant to combating climate change by reducing greenhouse gas concentration and aligning with sustainable goals related to carbon reduction, conservation, and responsible land management. It underscores the critical importance of forests in the fight against climate change and the promotion of sustainable and resilient environments.